History is often viewed as a finished book, its pages written in the ink of established consensus. However, beneath the layers of sediment and the weight of centuries, the Earth holds secrets that refuse to remain silent. Today, we stand at a crossroads of discovery. Advanced technologies are allowing us to peer into the deep past with unprecedented clarity, unearthing artifacts and structures that defy our current timelines. These findings do not merely add a footnote to our understanding. They threaten to dismantle the very foundations of what we thought we knew about human civilization. From sophisticated submerged cities to complex engineering found in unexpected eras, the evidence is mounting. As historians, we must remain objective and open to the possibility that our ancestors were far more capable than previously imagined. Let us examine the evidence that is forcing us to rewrite the narrative of our collective past. The earth beneath our feet is a meticulous ledger of time. Each layer of sediment, each distinct band of clay, silt, or volcanic ash represents a chronological chapter in a story that spans millions of years. For the archaeologist and the geologist, these layers are known as strata. The study of their arrangement, called stratigraphy, is the fundamental method by which we reconstruct the history of our planet and our species. Under the standard archaeological model, the deeper we dig, the more primitive the artifacts should become. We expect to find the remains of industrial societies near the surface, and beneath them, the stone tools of our hunter-gatherer ancestors. This orderly progression from simple to complex has been the backbone of historical education for over a century. However, recent discoveries at various sites around the globe have revealed a series of anomalies that refuse to fit into this neat chronological structure. These are the whispers from the stratum, subtle and sometimes startling clues that suggest human history may be far older and significantly more complex than the established narrative currently allows. To understand why these findings are so disruptive, one must first understand the law of superposition. Formulated in the 17th century by the Danish scientist Nicholas Steno, this principle states that in an undeformed sequence of sedimentary rocks, each layer is older than the one above it and younger than the one below it. This provides a relative timeline for anything found within those layers. If an archaeologist finds a finely carved stone pillar buried beneath 20 feet of undisturbed soil that has been geologically dated to 12,000 years ago, the pillar must be at least that old. For decades, the academic consensus held that 12,000 years ago, humans were exclusively nomadic hunter-gatherers. They were thought to lack the social organization, the nutritional surplus, and the engineering knowledge required to move massive stones or create sophisticated art. Yet, the stratum tells a different story. One of the most profound examples of this discrepancy is found in southeastern Turkey at a site known as Göbekli Tepe. Before its excavation, historians believed that the transition from small bands of foragers to settled agricultural communities, often called the Neolithic Revolution, was the catalyst for complex society. The logic was simple. First, humans learned to farm. Then they stayed in one place. Then they developed a surplus of food which allowed for specialized labor, and finally they built temples and cities. Göbekli Tepe turned this sequence on its head. When researchers began excavating the site in the 1990s, they found massive T-shaped limestone pillars, some weighing as much as 20 tons, arranged in sophisticated circles. These pillars were decorated with intricate carvings of foxes, scorpions, and lions. The most shocking aspect of Göbekli Tepe was not just its existence, but its depth and its age. It was buried under a massive artificial mound, and the lowest layers were dated to roughly 9,600 years before the Common Era. This places the site at the very end of the last ice age, a time when, according to the standard model, such monumental architecture should have been impossible. There was no evidence of domesticated grain or permanent housing nearby, suggesting that the builders were still hunter-gatherers. This discovery forced a radical reconsideration of human development. It suggested that the drive to create sacred spaces and engage in complex social rituals may have actually preceded the invention of agriculture, rather than being a byproduct of it. The whispers from the deep soil at Göbekli Tepe told us that our ancestors were far more capable and organized than we had ever dared to imagine. The challenge presented by deep stratum evidence is not limited to the Middle East. Across the world, in the rainforests of Indonesia, another site known as Gunung Padang has become a focal point of intense debate. To the casual observer, Gunung Padang looks like a natural hill topped with ancient stone terraces. However, some geologists and archaeologists who have conducted deep subsurface scans and core drilling suggest that the hill is actually a massive man-made step pyramid. Carbon dating of organic materials found in the deeper layers of the structure has yielded dates that are staggering. Some samples suggest that the earliest layers of the site were constructed as far back as 25,000 years ago. If these dates are verified and the structure is proven to be artificial, it would predate the oldest known civilizations by nearly 20,000 years. The academic community remains deeply divided over Gunung Padang. Critics argue that the deep layers may be natural volcanic formations rather than man-made masonry, and that the carbon samples might be contaminated. This skepticism is a necessary part of the scientific process, as extraordinary claims require extraordinary evidence. Yet, the possibility remains that beneath the surface lies a testament to a forgotten epoch of human history. If a sophisticated society capable of monumental construction existed during the height of the last glacial maximum, it would fundamentally change our understanding of human resilience and technological progress. It would mean that civilizations have risen and fallen many times over, lost to the cycles of climate change and the relentless accumulation of Earth. The difficulty in accepting these deep stratum findings often lies in our reliance on the existing archaeological timeline. This timeline is built upon the absence of evidence. Because we had not found any cities older than 5,000 years, we assumed that no cities existed before that time. But archaeology is an incomplete science. Most of the artifacts left behind by ancient peoples, such as wood, bone, and fiber, decay rapidly. Only stone, baked clay, and certain metals survive the passage of millennia. Furthermore, the vast majority of the Earth's surface has never been excavated. We are looking at a few scattered puzzle pieces and trying to describe the entire picture. When we find something like the Antikythera mechanism, an ancient Greek computer found in a shipwreck, or the massive megaliths of Malta, we are reminded that ancient peoples possessed a level of sophistication that often matches or exceeds our own in specific areas. The process of dating these deep finds is also fraught with complexity. Radiocarbon dating measures the decay of carbon-14 in organic materials, but it is only accurate up to about 50,000 years. Beyond that, researchers must rely on other methods like thermoluminescence, which measures the last time a mineral was exposed to sunlight, or potassium-argon dating for volcanic layers. Each of these methods has a margin of error and requires specific conditions to be reliable. When an artifact is found in a stratum that challenges the established timeline, the first reaction of the scientific community is often to question the dating method or the integrity of the soil layer. It is a constant battle between the desire to discover the truth and the need to maintain the rigors of the scientific method. There is also the matter of the Younger Dryas period, a sudden and catastrophic cooling event that occurred approximately 12,800 years ago. Geological evidence suggests that this period was marked by massive floods, rapid sea level rise, and the extinction of many large mammal species. Many of the sites that challenge our history, including Göbekli Tepe, appear to have been built or modified around this time of extreme environmental instability. Some researchers propose that a global cataclysm at the end of the Pleistocene epoch may have wiped out earlier civilizations, leaving only the most durable stone structures behind. These survivors would have been buried by the resulting floods and sedimentation, hidden deep within the stratum until modern technology allowed us to peer beneath the surface. As we continue to explore the depths of the Earth, we are essentially reading a forgotten diary of our species. The whispers from the stratum are growing louder with every new excavation and every advancement in ground-penetrating radar. We are finding that the story of humanity is not a straight line of constant progress, but rather a series of peaks and valleys, of grand achievements followed by periods of silence. The evidence buried deep beneath us suggests that we are a species with amnesia, slowly rediscovering the footprints of those who came before. These findings do not just change the dates in a textbook. They change our understanding of who we are and what we are capable of. They remind us that the Earth is a vast archive, and we have only just begun to turn the pages of its oldest chapters. The study of these ancient layers is a humbling reminder that even our greatest monuments will one day be buried, becoming the whispers that a future civilization will strive to understand. To understand why certain archaeological discoveries send shockwaves through the academic community, one must first understand the established timeline of human progress. For decades, the consensus was clear. After the last ice age ended roughly 11,500 years ago, humans slowly transitioned from small, nomadic bands of hunter-gatherers into settled farming communities. This process, known as the Neolithic Revolution, was thought to be the necessary precursor to everything we define as civilization. It was believed that only after the invention of agriculture could a society produce enough surplus food to support specialists like priests, architects, and stonemasons. This logical progression suggested that monumental architecture and complex social hierarchies could not have existed before approximately 6,000 years ago. However, buried deep within the soil of southeastern Turkey and other remote corners of the globe, evidence has emerged of an epoch that should not exist according to this traditional model. The primary disruptor of this historical narrative is the site of Göbekli Tepe. Discovered in the mid-1990s by German archaeologist Klaus Schmidt, this site dates back nearly 12,000 years. This placement in time is not merely a minor adjustment to our calendars. It is a fundamental challenge to our understanding of human capability. At Göbekli Tepe, we find massive, T-shaped limestone pillars, some weighing as much as 20 tons and standing nearly 20 feet tall. These pillars are arranged in massive circles, many of them featuring intricate, high-relief carvings of animals such as lions, foxes, scorpions, and vultures. The problem for historians is that there is no evidence of domesticated crops or permanent housing at the site during its earliest and most sophisticated phases. The people who built this massive complex were, by all current definitions, hunter-gatherers. According to the traditional textbook, they should have been struggling for daily survival, yet they managed to organize hundreds of laborers, extract massive stones from a nearby quarry without metal tools, and transport them to a hilltop to create a temple of immense symbolic complexity. This suggests that organized religion and social hierarchy did not follow the invention of agriculture, but may have actually preceded it. It suggests that a deep spiritual motivation drove people to settle down and eventually innovate farming to feed the workers gathered at these holy sites. As we look deeper into this epoch, we find that Göbekli Tepe is not an isolated anomaly. Recent surveys in the same region have identified several other hills, collectively known as the Taz Tepeler, which contains similar monumental structures. One such site, Karahan Tepe, features even more startling artistic expressions, including a human head carved directly into the bedrock and a series of pillars that suggest a mastery of three-dimensional space that was previously thought impossible for that era. These sites indicate a widespread, sophisticated culture that flourished at the very end of the Pleistocene epoch, a time when the world was undergoing violent climatic shifts. The existence of such advanced engineering during this period brings us to the mystery of the Younger Dryas. Between 12,900 and 11,600 years ago, the Earth experienced a sudden and dramatic return to glacial conditions. This period, characterized by extreme temperature fluctuations and massive flooding, would have been a catastrophic time for any burgeoning civilization. The fact that the most sophisticated layers of Göbekli Tepe are the oldest ones suggests a strange reversal of typical cultural evolution. Instead of starting simple and becoming more complex over time, the site began at its architectural peak and gradually declined in quality before being intentionally buried and abandoned. This raises the haunting question of whether these people were not at the dawn of their development, but were perhaps the inheritors of an even older tradition of knowledge that was struggling to survive a global cataclysm. The implications of an epoch that should not exist extend far beyond the borders of Turkey. In West Java, Indonesia, a site known as Gunung Padang sits atop a prominent hill. While the surface features are relatively recent megalithic structures, ground-penetrating radar and core drilling have suggested that the hill itself may be a massive, man-made pyramid built in successive layers. Some of the lower layers have been carbon-dated to over 20,000 years ago. If these dates are ever fully verified, they would place the origins of monumental construction in the heart of the last ice age, a time when humans were supposed to be living in simple caves and temporary shelters. While many mainstream geologists argue that the lower layers of Gunung Padang are natural rock formations, the debate itself highlights the tension between established chronological models and new, disruptive data. The technological paradox of this era is perhaps the most difficult aspect for modern historians to reconcile. When we examine the precision with which stones were shaped and joined at these ancient sites, we are forced to ask what tools were used. The conventional view is that these people used nothing more than harder stones, like diorite or obsidian, to pound away at the limestone. While this is theoretically possible, the level of artistic detail and the sheer scale of the projects imply a level of engineering foresight and mathematical understanding that we usually associate with much later civilizations like those of Egypt or Mesopotamia. Furthermore, the orientation of these sites often suggests an advanced knowledge of astronomy. Many of the enclosures at Göbekli Tepe appear to be aligned with specific celestial bodies or events, such as the rising of Sirius or the summer solstice. This implies that these early people had been observing the stars for generations, recording cycles and patterns that would eventually become the foundation of our modern calendar. To possess such knowledge, a society requires a degree of continuity and intellectual specialization that the hunter-gatherer model simply does not allow for. As we analyze the stratigraphy of these sites, we see a pattern of sudden appearance and sudden disappearance. There are no clear developmental stages leading up to the mastery shown at the Taz Tepeler sites. It is as if the knowledge of how to build, carve, and organize suddenly materialized out of the void. This leads some researchers to propose the existence of a ghost civilization, a lost cultural layer that existed during the Ice Age, but was largely wiped out by the rising sea levels and climatic chaos of the Younger Dryas. Since most prehistoric populations lived near coastlines, the melting of the great ice sheets would have submerged the vast majority of their settlements under hundreds of feet of water, leaving only the highland outposts like those in Turkey or Indonesia for us to find. If we accept the possibility of this earlier epoch, we must also reconsider the nature of human history itself. We often view history as a straight line of progress, moving from primitive to advanced, from simple to complex. However, the evidence from these deep layers suggests a more cyclical or broken narrative. It suggests that humanity may have reached significant heights of social and technological organization long before the written word, only to be forced back into a state of survival by planetary-scale disasters. The epoch that should not exist serves as a profound reminder of the limitations of our current archaeological record. We are working with a fragmented puzzle, where most of the pieces have been destroyed by time, weather, and geological upheaval. When we find a site that defies our models, it is an invitation to expand our perspective rather than to dismiss the evidence as an impossibility. The deep layers of the earth do not care about our academic consensus. They simply hold the truth of what came before, waiting for us to develop the tools and the open-mindedness required to read them. The transition from the Ice Age into the Holocene was not just a change in weather. It was a period of profound transition that may have seen the end of one chapter of the human story and the stuttering, difficult beginning of another. As we continue to dig, we find that the roots of our civilization are far deeper and much more complex than we ever dared to imagine. The monuments of this forgotten epoch stand as silent witnesses to a time when humanity was already dreaming of the stars and carving its legacy into the very bones of the earth, long before the first grain of wheat was ever planted. This realization forces us to confront the fact that we are a species with a very short memory, living on a planet that has seen many worlds rise and fall before our own. In the next stage of our investigation, we will look at how this lost knowledge might have been transmitted across the ages, and the strange artifacts that suggest a shared heritage between cultures separated by vast oceans and thousands of years. When we examine the archaeological record, we typically expect to see a linear progression of technology. We look for a logical sequence where simple stone tools gradually give way to copper, then bronze, then iron, and eventually to the complex mechanical and digital systems of the modern age. This narrative of steady, upward advancement is comfortable and easy to teach, but it is frequently disrupted by the discovery of artifacts that simply do not fit. These objects, often categorized by researchers as out-of-place artifacts, exhibit a level of technical sophistication that seems to belong to a much later period of history. As we delve into these relics of an impossible ingenuity, we must adopt the mindset of an investigator who is willing to question the standard timeline of human development. We are not looking for evidence of the supernatural, but rather for evidence of a high level of human achievement that was somehow lost to the sands of time. Perhaps the most famous example of such an object is the Antikythera mechanism. Discovered by sponge divers in 1901 within the remains of a Roman shipwreck near the Greek island of Antikythera. This device sat in a museum for decades before its true nature was understood. At first glance, it appeared to be a calcified lump of bronze and wood. However, through the use of advanced X-ray imaging and three-dimensional CT scans, researchers revealed a complex system of over 30 interlocking bronze gears. This device dates back to at least the 2nd century before the Common Era. It is, by all functional definitions, an analog computer. The Antikythera mechanism was designed to track the movements of the Sun, the Moon, and the 5 planets known to the ancient Greeks. It could predict solar and lunar eclipses with startling accuracy, even accounting for the elliptical orbit of the Moon, a concept that was thought to have been understood much later in history. The level of mathematical knowledge required to design these gear ratios is staggering. To find anything of comparable mechanical complexity, we have to look forward more than 1,000 years to the development of astronomical clocks in medieval Europe. This suggests that during the Hellenistic period, there was a peak of mechanical engineering that vanished, leaving behind only this solitary, rusted witness to a forgotten brilliance. We must ask ourselves how many other such devices existed and why the knowledge required to build them did not survive the collapse of the ancient world. The mystery of ancient ingenuity is not limited to mechanical devices. It is also carved into the very stone of our planet. In the high altitudes of the Bolivian Andes, we find the archaeological site of Pumapunku. This site features massive blocks of andesite and diorite, some of which weigh over 100 tons. What makes Pumapunku extraordinary is not just the size of the stones, but the precision with which they were cut. The blocks feature perfectly straight edges, internal right angles, and intricate decorative carvings that look as though they were created using modern CNC milling machines. In many cases, the stones are so flat that a razor blade cannot be inserted between them. Conventional archaeological theories suggest that these stones were shaped using stone hammers and basic abrasive tools. However, when we consider the hardness of diorite, this explanation becomes difficult to sustain. To achieve such flat surfaces and precise angles on such hard material would require tools of even greater hardness, such as diamond-tipped saws or advanced polishing wheels. Furthermore, the logistical challenge of transporting these massive blocks across rugged terrain without the use of the wheel or draft animals remains a point of intense academic debate. These ruins suggest a mastery of geology and civil engineering that rivals our own, yet they were produced by a culture that, according to the standard record, lacked the very tools necessary to create them. As we move from the mountains of South America to the shores of the Mediterranean, we encounter another example of ancient chemical ingenuity. The Lycurgus cup is a 4th century Roman glass chalice that depicts the death of King Lycurgus. What makes this cup unique is its dichroic property. When lit from the front, the glass appears green, but when lit from behind, it glows a vibrant ruby red. For centuries, this was considered a miracle of craftsmanship. It was only in 1990 that scientists analyzed fragments of the glass under an electron microscope and discovered the reason for this color change. The Roman artisans had infused the glass with particles of silver and gold that were ground down to approximately 50 nanometers in diameter. This is roughly 1,000th the size of a grain of table salt. By manipulating matter at the atomic level, the Romans had essentially created a form of nanotechnology. The precision required to achieve the exact ratio of precious metals necessary for this effect suggests that this was not an accidental discovery. It implies a sophisticated understanding of chemistry and metallurgy that was far ahead of its time. We are forced to consider the possibility that ancient laboratories were conducting experiments that we are only now beginning to replicate with our most advanced equipment. This pattern of lost technological peaks continues when we look at the history of metallurgy, specifically the creation of Damascus steel. For centuries, swords made from this material were legendary for their strength, flexibility, and their ability to hold a razor-sharp edge. They were identifiable by the distinct watery pattern on the surface of the blades. The steel was originally produced using wood steel ingots from India and processed in the Middle East. However, the secret of its manufacture was lost sometime in the 18th century. Modern researchers, using high-resolution microscopy, discovered that the strength of Damascus steel was due to the presence of carbon nanotubes and cementite nanowires within the metal. These structures provided the blade with its incredible durability. The ancient smiths had developed a complex thermal processing technique that allowed these microscopic structures to form, centuries before the formal discovery of carbon nanotubes in the 20th century. This is another clear instance where an ancient craft reached a level of technical excellence that modern science struggled for decades to understand or reproduce. Another curious artifact is the Roman dodecahedron. These are small, hollow objects made of bronze or stone, with 12 flat pentagonal faces. Each face has a circular hole in the center, and the vertices are adorned with small knobs. Over 100 of these have been found across the former Roman Empire, particularly in regions that were once part of Gaul and Germania. Despite their prevalence, there is no mention of them in any surviving Roman literature or technical manuals. Their purpose remains an absolute mystery. Scholars have proposed dozens of theories. Some suggest they were used as rangefinders for Roman artillery, while others believe they were astronomical instruments used to determine the optimal date for sowing grain. Some even suggest they were used as knitting tools for gloves. The sheer variety of theories highlights a significant gap in our understanding of Roman daily life and technical capabilities. These dodecahedrons represent a specialized knowledge that was once commonplace enough to be mass-produced, yet it was so completely erased from the historical record that we can only guess at their function today. We must also consider the controversial Baghdad Battery. Discovered in the 1930s near the ancient city of Baghdad, these artifacts consist of a clay jar, a copper cylinder, and an iron rod. When filled with an acidic substance like vinegar or lemon juice, these components can produce a small electric current. While many mainstream archaeologists remain skeptical that these were used as actual batteries, experiments have shown that they could have been used for electroplating jewelry with gold or silver. If this is the case, it would mean that the principles of electricity and electrochemistry were understood and utilized over 1,000 years before the work of Alessandro Volta. Even if they were not used for electricity, the sophisticated assembly of these components shows a deep understanding of how different materials interact in a controlled environment. Each of these artifacts, from the geared mechanisms of Greece to the nanostructures of Roman glass, serves as a challenge to our perception of the past. They suggest that human history is not a steady climb, but a series of dramatic rises and falls. We see evidence of civilizations reaching incredible heights of technical mastery, only for that knowledge to be extinguished by war, famine, or environmental collapse. The loss of such information is a sobering reminder of the fragility of our own technological achievements. When we view these relics through an academic lens, we see that the people of antiquity were just as intelligent and creative as we are today. They faced similar problems and developed ingenious solutions, some of which we are only now beginning to rediscover. These objects are not impossible because they were made by outsiders. They are impossible because they force us to admit how much we have forgotten about our own history. They invite us to look deeper into the earth and more critically at the texts we have inherited. As we conclude this examination of lost ingenuity, we are left with a new perspective on the capabilities of our ancestors. The evidence buried deep beneath the earth does more than just fill in the gaps of our knowledge. It completely reshapes the framework through which we view the human story. We begin to see a world where the boundaries of the possible were constantly being pushed, and where the treasures of the past are not just gold and jewels, but the echoes of a profound and sophisticated intelligence that once flourished in the shadows of the ancient world. These relics are the keys to a history that is far more complex and far more impressive than we ever dared to imagine. To understand the true depth of the mystery surrounding our ancestors, we must first look toward the horizon and then beneath the waves. For the vast majority of human history, the world looked radically different than the maps we consult today. During the height of the last glacial period, immense quantities of the Earth's water were locked away in massive ice sheets, some of which were miles thick. This sequestration of water caused global sea levels to sit approximately 120 meters lower than they do in the modern era. As a result, millions of square miles of what is now the ocean floor were once dry, fertile, and immensely habitable land. These vast coastal plains were not merely margins of the continents. They were the prime real estate of the ancient world. They offered access to rich marine resources, temperate climates, and easy transportation routes along river estuaries. It is increasingly clear to many researchers that the most significant developments in early human society likely occurred on these now submerged plains. When the ice began to melt during the transition into the Holocene epoch, the rising tides did not just change the geography. They swallowed the evidence of our earliest civilizations. The realization that the cradle of humanity might actually be resting beneath the abyss has forced a massive shift in archaeological thinking. For decades, the standard narrative suggested that civilization began in the Fertile Crescents of Mesopotamia and Egypt roughly 5,000 or 6,000 years ago. However, this timeline is based almost entirely on evidence found on dry land. If the most advanced early cultures were coastal, as is the case with most modern populations, then their cities and sacred sites are currently resting under hundreds of feet of salt water and sediment. This is not a matter of mere speculation. Marine archaeology is now beginning to reveal the outlines of this lost world. We are finding that the continental shelves are littered with the remnants of human activity that predate the established record of urban development. One of the most compelling examples of this submerged history is found in the North Sea, in a region known as Doggerland. Once a vast, low-lying landscape that connected Great Britain to continental Europe, Doggerland was a heartland of the Mesolithic era. For thousands of years, it was a productive environment filled with lagoons, marshes, and rivers. As the climate warmed and the glaciers retreated, the rising North Sea slowly transformed this landscape into a series of islands before eventually submerging it entirely around 8,000 years ago. For a long time, the only evidence of Doggerland came from the nets of commercial fishermen, who would occasionally pull up prehistoric tools, mammoth bones, and even human remains from the sea floor. Today, sophisticated seismic mapping and underwater core sampling have allowed scientists to reconstruct the topography of this lost world. They have found evidence of massive river systems and ancient forests, confirming that this was not just a land bridge, but a thriving center of human life. The disappearance of Doggerland was not always a slow process. Evidence suggests that a catastrophic event known as the Storegga Slide, a massive underwater landslide off the coast of Norway, triggered a devastating tsunami that may have finally overwhelmed the remaining inhabitants of this low-lying territory. If we move our gaze to the Indian Ocean, the evidence for early submerged civilizations becomes even more challenging to the traditional historical timeline. In the Gulf of Khumbat, off the western coast of India, marine surveys conducted by the National Institute of Ocean Technology in the early 21st century revealed something truly startling. Using side-scan sonar, researchers identified two large, city-sized areas situated at a depth of about 40 meters. These features appear to show organized urban layouts, including what look like large granaries, defensive walls, and even a complex drainage system. Most provocatively, carbon dating of organic material recovered from the site, such as worked wood and pottery shards, suggested an age of over 9,000 years. If these dates are accurate, it would mean that a sophisticated urban society existed in the Indian subcontinent thousands of years before the rise of the Indus Valley civilization. While many in the traditional archaeological community remain skeptical, arguing that the sonar images might be natural geological formations and that the artifacts could have been washed into the area by ancient rivers, the sheer scale and geometric regularity of the features continue to demand further investigation. The Mediterranean Sea also holds secrets that challenge our understanding of the Neolithic transition. Off the coast of Israel lies the submerged village of Atlit Yam. Unlike many other underwater sites that are heavily eroded or buried in deep silt, Atlit Yam is remarkably well preserved. It dates back roughly 9,000 years and provides a vivid snapshot of a community caught between the old ways of hunting and gathering and the new world of agriculture. Divers have documented stone houses, paved floors, and even a ritual site consisting of a circle of standing stones around a freshwater spring. Perhaps most fascinating is the discovery of a deep well, which demonstrates that these ancient people possessed sophisticated engineering skills. The presence of domesticated animal bones and harvested grain shows that they were already successful farmers. Atlit Yam was eventually abandoned as sea levels rose, but its existence proves that highly organized, sedentary communities were flourishing in coastal areas long before the construction of the pyramids or the rise of Sumerian city-states. The difficulty of exploring these sites cannot be overstated. Marine archaeology is an expensive, dangerous, and technically demanding field. Unlike terrestrial excavations where a researcher can spend months meticulously brushing away layers of soil, underwater archaeologists must contend with powerful currents, limited visibility, and the crushing pressure of the depths. Often, the very sites they wish to study are buried under meters of shifting sand or calcified marine growth. Furthermore, the salt water itself is a destructive force, corroding metals and rotting organic materials unless they are quickly buried in anaerobic conditions. This means that for every site we have found, there are likely thousands more that have been eroded away or remain hidden in the gloom of the abyss. Despite these challenges, the technological tools available to historians and archaeologists are evolving rapidly. We are no longer limited to what a diver can see through a mask. Remotely operated vehicles equipped with high-definition cameras and robotic arms allow us to explore depths that were previously unreachable. Autonomous underwater vehicles can map vast swaths of the ocean floor with centimeter-level precision using multi-beam sonar. These technologies are revealing that the continental shelves are not empty voids, but are instead vast graveyards of human ambition. We are seeing patterns of settlement that suggest a much more mobile and maritime-oriented prehistoric population than we previously imagined. This leads us to a fundamental question. If the evidence for the earliest stages of civilization is buried beneath the sea, how much of our history is missing? The traditional model of human progress is a linear one, moving from simple stone tools to agriculture, then to cities, and finally to writing. But if urban centers existed 9,000 or even 12,000 years ago on the coasts of India, Southeast Asia, or the Mediterranean, then our linear model is flawed. It suggests that civilization did not just happen once in a few specific river valleys. Instead, it may have been a recurring phenomenon that was repeatedly disrupted by dramatic climatic shifts and rising oceans. We must consider the possibility that the end of the last ice age was a period of profound trauma and loss for the human species. The submergence of the continental shelves represented the loss of millions of square miles of the most productive land on Earth. As the waters rose, entire cultures would have been forced to migrate inland, likely coming into conflict with existing populations and losing much of their material heritage in the process. The stories of great floods that permeate the mythologies of cultures all over the world, from the Sumerian epic of Gilgamesh to the legends of the indigenous peoples of the Americas, may not be mere metaphors. They may be the echoes of a real, global catastrophe that erased the first chapters of the human story. As we look deeper into the abyss, we are not just finding ruins. we are finding a new perspective on our own resilience. The people who lived in Doggerland or at Lityam were not primitive in the sense of being less capable or less intelligent. They were masters of their environment, capable of building enduring structures and managing complex resources. The fact that their worlds are now underwater is a reminder of the power of the Earth's natural cycles and the fragility of human achievement. The cradles beneath the abyss represent a silent challenge to our current understanding of time and progress. They suggest that the deep past is far more crowded with activity and innovation than we ever suspected. To find the truth about our origins, we must be willing to look where we have never looked before, in the dark, cold reaches of the drowned world. Each new discovery from the seafloor acts as a bridge, connecting us to a version of ourselves that we had almost entirely forgotten. The evidence is there, waiting in the silence, challenging everything we thought we knew about the dawn of civilization. To understand the full scope of human history, we must look beyond the physical ruins and the carved stones that have survived the passage of millennia. We must look into the very core of our being, into the microscopic strands of DNA that carry the silent testimony of our ancestors. In recent decades, the field of paleogenetics has undergone a revolution, one that is rewriting the story of who we are and where we came from. This scientific frontier has revealed something startling. Our genetic code contains the signatures of lost peoples, groups of ancient humans who left no skeletons, no tools, and no recognizable settlements. In the language of science, these are known as ghost lineages. For most of the 20th century, the prevailing narrative of human evolution was relatively straightforward. We believed that modern humans evolved in Africa and eventually moved out to replace other, more primitive hominins like the Neanderthals. It was a story of linear progression and eventual dominance. However, as we began to sequence the genomes of ancient remains and compare them to modern populations, the picture became vastly more complex. We discovered that the human family tree is not a single trunk but a tangled web of interconnected branches, many of which we are only now beginning to identify. The first major shock to the traditional narrative came with the discovery of the Denisovans. In 2008, a tiny fragment of a finger bone was found in Denisova Cave in the Altai Mountains of Siberia. By all appearances, it was an unremarkable find. Yet, when scientists extracted and sequenced the DNA from this bone, they realized they were looking at something entirely new. This individual was neither a modern human nor a Neanderthal. They belonged to a distinct group that had diverged from a common ancestor hundreds of thousands of years ago. The true revelation, however, was not just that the Denisovans existed, but that they had never truly disappeared. When researchers compared Denisovan DNA to the genomes of people living today, they found significant matches. Specifically, populations in Melanesia, Aboriginal Australians, and some groups in Southeast Asia carry as much as 5% Denisovan DNA. This means that at some point in the deep past, modern humans and Denisovans met, lived together, and produced offspring. The Denisovans were not a separate, failed branch of humanity. They are a part of us. But the mystery goes deeper than the Denisovans. As our mapping techniques improved, we began to see evidence of other groups that we have never even found in the fossil record. These are the true ghost lineages. Statistical models of the human genome have identified genetic signatures that do not match Neanderthals, Denisovans, or modern humans. In West Africa, for example, studies have shown that modern populations carry the genetic legacy of an unknown archaic ancestor. This group likely diverged from the human line hundreds of thousands of years ago and remained isolated until they eventually interbred with the ancestors of modern West Africans. We have no bones for this group, no stone tools we can definitively link to them, and no idea what they looked like. They exist only as a shadow in our genetic code. This phenomenon is not isolated to Africa. Similar signals have been found in populations across Asia and Oceania. There is evidence of a super-archaic lineage, a group that may have diverged from the main human line as long as 2 million years ago. This group would have been even more distant from us than the Neanderthals were. Yet, their genetic markers persist in certain modern groups, suggesting a history of contact and integration that spans the entire globe. The implications of these findings are profound. They challenge the very definition of what it means to be human. If our ancestors were regularly interbreeding with different groups of archaic humans, then the idea of a pure or singular human origin becomes obsolete. We are a mosaic of different lineages, a biological synthesis of various human forms that once walked the earth. This suggests that the ancient world was far more crowded and far more socially complex than we ever imagined. Imagine a world where multiple different types of humans lived side by side. They would have possessed different physical traits, perhaps different ways of communicating, and different methods of surviving in their environments. Far from being a story of competition and replacement, the genetic evidence suggests a story of interaction. These were not different species in the way we traditionally think of them. They were different enough to be distinct, but similar enough to recognize each other as kin. This leads us to a difficult question for historians and archaeologists. If these ghost lineages existed for hundreds of thousands of years, what kind of cultures did they build? If we have found their DNA but not their bones, it is highly likely that we have also found their artifacts but have attributed them to the wrong people. Many of the stone tools found in various parts of the world that do not quite fit the standard patterns of Neanderthals or early modern humans may actually be the work of these lost groups. The silence of the fossil record does not mean a lack of activity. It simply means that the conditions for preservation were not met. The discovery of ghost lineages also forces us to reconsider the timeline of human migration. The presence of Denisovan DNA in island populations of Southeast Asia suggests that these ancient humans were capable of crossing significant water barriers long before modern humans arrived in the region. It implies a level of technological and cognitive sophistication that we have long reserved for ourselves. If these archaic groups were navigating the seas and adapting to diverse climates, we must ask what else they were capable of. Furthermore, these genetic anomalies offer a new perspective on human health and adaptation. Some of the genes we inherited from these ghost lineages have been crucial to our survival. For example, a gene variant that allows Tibetans to live at high altitudes with low oxygen levels was inherited directly from the Denisovans. In other populations, genes related to immune system function and skin pigmentation can be traced back to archaic ancestors. These were not just random bits of junk DNA. They were functional, beneficial traits that helped modern humans survive as they moved into new and challenging environments. The study of ghost lineages is still in its infancy. Every year, new techniques are developed to extract DNA from soil, from ancient teeth, and even from the air inside caves. We are no longer limited by the presence of a complete skeleton. We are learning to read the environment itself for the traces of those who came before. As we do, the number of ghost lineages is likely to grow. We may find that the human story is not one of a single migration out of Africa, but of many pulses of movement, many layers of occupation, and a constant process of mixing and merging. This biological reality turns our traditional historical models upside down. We have often viewed history as a series of distinct chapters, each defined by a particular group of people. But genetics tells us that the chapters bleed into one another. The boundaries we draw between ourselves and the people of the past are largely artificial. We carry the ancient world within us. The ghost lineages are not gone. They are present in the way our bodies function, the way we fight off disease, and the very structure of our brains. As we move forward, we must integrate this genetic data with our archaeological findings. We must look at the deep layers of the earth not just for what we can see, but for the microscopic evidence of who was there. The silence of the past is being filled with a complex, multi-voiced chorus. We are beginning to hear the stories of the people who left no monuments, the groups who vanished into the shadows of time but left their mark in the blood of their descendants. The existence of these genetic anomalies reminds us that we are still only scratching the surface of our own history. We are a young species with a very old and complicated heritage. The more we learn, the more we realize that the human experience has always been defined by connection rather than isolation. The evidence buried deep within ourselves is perhaps the most challenging evidence of all, because it requires us to rethink our place in the natural world and our relationship to the many kinds of humans who came before us. The quest to identify these ghost lineages is more than just a scientific endeavor. It is a search for our lost relatives. It is an acknowledgement that the human family is much larger and more diverse than we were taught to believe. By studying these genetic shadows, we are giving a voice to the voiceless. We are ensuring that the people who were nearly erased from history are finally recognized as part of the great human tapestry. The story of our origins is being rewritten, and the new version is far more extraordinary than anything we could have imagined. This genetic journey is only beginning, and it promises to reveal even more about the hidden depths of our shared past. To understand why certain discoveries remain buried in the literal and metaphorical sense, one must first understand the structure of the scientific community. Science is often presented as a fluid and ever-changing pursuit of truth, but it is also a human institution. Like any institution, it possesses a set of established beliefs, a hierarchy of authority, and a protective shell designed to filter out ideas that seem too radical or unsubstantiated. This is what many historians and philosophers of science refer to as scientific orthodoxy. It is a fortress built on decades of research, peer-reviewed publications, and the hard-won reputations of scholars who have dedicated their lives to a particular version of history. While this fortress serves a vital purpose by preventing every wild claim from being accepted as fact, it can also become a barrier to genuine progress when the evidence buried deep in the earth begins to contradict the foundational stones of the building. The concept of a scientific paradigm was popularized by Thomas Kuhn in the middle of the 20th century. He argued that science does not progress in a straight, linear fashion. Instead, it operates within a stable framework until that framework can no longer support the weight of its own contradictions. Archaeology and anthropology are perhaps more susceptible to this kind of institutional inertia than any other field. This is because the physical evidence of the past is often fragmented, fragile, and subject to intense interpretation. When an archaeologist finds a stone tool or a hearth in a layer of soil that is supposed to be hundreds of thousands of years old, they are not just presenting a piece of rock. They are challenging the very narrative that their colleagues have taught in classrooms for generations. Consider the history of the settlement of the Americas. For the better part of the 20th century, the Clovis first hypothesis was the absolute law of the land. This theory stated that the first humans arrived in the New World roughly 13,000 years ago, traveling across the Bering Land Bridge and through an ice-free corridor in what is now Canada. These people were identified by their distinct, elegantly fluted stone spear points, first discovered near Clovis, New Mexico. The Clovis first model was elegant, it was logical, and it fit the available climate data of the time. However, it also became an ideological fortress. For decades, any researcher who claimed to find evidence of human presence older than 13,000 years was met with intense skepticism and, in some cases, professional hostility. This period of archaeological history is often referred to by younger scholars as the era of the Clovis police. Those who guarded the orthodoxy were not malicious, but they were deeply invested in the established model. When discoveries were made at sites like Monte Verde in Chile, which suggested a human presence at least 14,500 years ago, the initial reaction from the academic community was one of dismissal. Critics argued that the dating was wrong, or that the artifacts were actually natural stones shaped by water, or that the layers of soil had been mixed by burrowing animals. It took nearly 20 years of rigorous re-excavation, site visits by committees of experts, and an overwhelming mountain of data before the walls of the Clovis first fortress finally began to crumble. This transition was not a polite conversation. It was a long and bitter struggle that illustrated how difficult it is for the scientific establishment to accept evidence that requires a total rewrite of the textbook. The resistance to new ideas often stems from the way academic careers are built. Tenure, grants, and publishing opportunities are frequently tied to how well a researcher's work aligns with the prevailing theories of the time. A young doctoral student who proposes a theory that contradicts their advisor's lifelong work is taking a significant professional risk. In this environment, the fortress of orthodoxy is maintained not just by evidence, but by the social and economic structures of the university system. This creates a psychological phenomenon known as confirmation bias, where researchers unconsciously favor information that supports their existing beliefs while ignoring or explaining away data that challenges them. In the case of deep history, this bias often manifests in the way we view the capabilities of ancient humans. There is a persistent, if unspoken, assumption that human progress has been a steady climb from primitive simplicity to modern complexity. When evidence appears that suggests ancient people possessed sophisticated knowledge of astronomy, engineering, or seafaring much earlier than we thought, it is often treated as an anomaly or a mystery rather than a reason to rethink the timeline. These anomalies are the cracks in the fortress walls. For example, the discovery of the Cerruti mastodon site in California presented evidence of hominins processing animal remains 130,000 years ago. This date is so far outside the accepted window for human arrival in North America that many scientists simply refuse to engage with it, despite the rigorous nature of the taphonomic studies conducted at the site. The standard response to such radical evidence is the famous maxim that extraordinary claims require extraordinary evidence. While this is a sound scientific principle, the definition of what constitutes extraordinary is often subjective. For a researcher within the fortress, no amount of evidence may feel sufficient to overturn a core belief. This leads to a situation where the burden of proof is placed entirely on the challenger, while the existing theory is allowed to stand even if it is no longer the best explanation for the totality of the data. The fortress is designed to be defensive, but when it becomes too rigid, it risks becoming a tomb for the truth. Technology is the siege engine that is currently battering the walls of scientific orthodoxy. The advent of carbon dating in the middle of the 20th century was the first major blow, forcing a massive reorganization of European prehistory. Today, the tools are even more powerful. Genomic sequencing and LiDAR, or light detection and ranging, are revealing hidden chapters of the human story that were previously invisible to the naked eye. LiDAR can see through the dense canopy of the Amazon rainforest or the jungles of Central America to reveal massive, interconnected urban complexes where we once thought only small, nomadic tribes existed. These discoveries do not just add new details to our maps. They challenge the narrative that these environments could not support large-scale civilizations. As these new technologies provide more data, the academic community is forced into a state of cognitive dissonance. The old models are clearly insufficient, yet the new models are still being formed. This is the stage of a paradigm shift where the most tension exists. We see this today in the debate over the origins of agriculture, the timing of the first seafaring expeditions, and the possibility of lost coastal civilizations that were submerged by rising sea levels at the end of the last ice age. The evidence is buried deep, often underwater or under layers of sediment that were previously thought to be sterile of human activity. The transition from one scientific consensus to another is rarely a sudden event. It is more like a slow erosion. One by one, the defenders of the old guard retire or pass away, and a new generation of researchers who grew up with the new data takes their place. There is a famous saying in the history of science that a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it. While this may sound cynical, it highlights the deeply human element of our search for the past. We are not just data processing machines, we are storytellers who become attached to the stories we tell. The fortress of scientific orthodoxy is not an evil entity. It is a necessary part of the process of vetting information. Without it, our understanding of history would be a chaotic mess of unsubstantiated claims and fringe theories. However, the expert historian must recognize when the fortress has stopped protecting the truth and has started protecting itself from the truth. The evidence buried deep in the earth, the genetic markers in our blood, and the ruins hidden beneath the sea are all calling for a more flexible, more courageous approach to history. They remind us that our current understanding is merely a snapshot in time, a temporary map of a much larger and more mysterious territory. As we move forward, the challenge for the scientific community is to maintain the rigor of the scientific method while remaining open to the possibility that our foundational assumptions could be wrong. It requires a certain intellectual humility to admit that the deeper we dig, the more we realize how much we have yet to learn. The fortress must be willing to renovate its halls and expand its walls to accommodate the new evidence that continues to emerge from the depths. Only then can we hope to move closer to a true understanding of the human story, a story that is far older, more complex, and more surprising than anything we previously imagined. This ongoing struggle between the established and the unknown is the very heart of the historical process, ensuring that the study of the past remains a living, breathing, and vital pursuit. As we synthesize the findings from across the globe, we are forced to admit that the traditional narrative of a single, linear expansion out of Africa is no longer sufficient to contain the complexity of our origins. For decades, the academic consensus focused on a singular event roughly 60,000 years ago. This hypothesis suggested that a small group of modern humans crossed the Red Sea and eventually populated the rest of the planet, replacing all other hominid species they encountered. However, the dirt under our fingernails and the sequences within our genomes now tell a far more intricate story. We are looking at a map that is not just a series of arrows pointing away from a central hub, but a tangled web of interactions, migrations, and unexpected detours. The shift begins with a fundamental reevaluation of our cousin species. Until very recently, the Neanderthal was depicted as a lumbering, dim-witted brute, a biological dead end that vanished when the superior Homo sapiens arrived on the scene. Yet, the evidence unearthed in the last 20 years has dismantled this caricature. We now know that Neanderthals possessed complex symbolic thought, buried their dead with care, and produced sophisticated tools. Most importantly, the mapping of the Neanderthal genome revealed that they never truly disappeared. They live on in us. Most people of non-African descent carry between 1 and 4% Neanderthal DNA. This single fact changes our understanding of the human journey from one of conquest and replacement to one of integration and hybridization. The map grew even more complex with the discovery of the Denisovans in the Altai Mountains of Siberia. A single fragment of a finger bone, recovered from a cave, provided enough genetic material to identify an entirely new branch of the human family tree. This group, which lived alongside both Neanderthals and modern humans, left their own genetic legacy, particularly in the populations of Southeast Asia, Australia, and Melanesia. The realization that at least 3 distinct types of humans were interacting and interbreeding across the vast landscapes of Eurasia is a profound departure from the older, more simplistic models. It suggests a prehistoric world that was much more crowded and intellectually diverse than we ever dared to imagine. This new map also requires a drastic revision of our timelines. In the Americas, the long-held Clovis first model has been effectively dismantled. For the better part of a century, archaeologists believed that the first people to enter the Western Hemisphere did so about 13,000 years ago, crossing a land bridge from Siberia and following an ice-free corridor into the heart of the continent. But sites like Monte Verde in Chile, which dates back at least 14,800 years, and the Paisley Caves in Oregon have pushed the arrival date back by thousands of years. The most shocking evidence of all came recently from the White Sands National Park in New Mexico. Footprints preserved in ancient lake beds have been dated to 23,000 years ago, during the height of the last glacial maximum. These dates are not just numbers on a chart. They represent a fundamental shift in our understanding of human capability. If people were in New Mexico 23,000 years ago, the ice-free corridor was still blocked by massive glaciers. This means the first Americans likely arrived by sea, skirting the coastline in skin boats and relying on the rich resources of the kelp forest. This coastal migration hypothesis suggests that early humans were much more than just terrestrial hunters following mammoths. They were skilled mariners, capable of navigating some of the most treacherous waters on Earth. The human journey was not just a walk across a land bridge. It was a maritime odyssey that required advanced knowledge of tides, currents, and aquatic ecology. The rethinking of the human map extends to the very cradle of our species as well. While Africa remains the primary origin point, we are learning that the continent itself was a scene of constant flux and regional specialization. Instead of a single Garden of Eden, we are seeing evidence of a Pan-African origin, where different groups across the continent evolved in semi-isolation before coming together to share genetic and cultural innovations. The discovery of fossils in Jebel Irhoud, Morocco, dated to 300,000 years ago, shows that the features of modern humans were appearing across the entire African landmass far earlier than previously thought. The map of Africa is being redrawn as a network of interconnected environments where the human form was refined over hundreds of millennia. Even the path out of Africa is being reconsidered. The traditional northern route through the Sinai Peninsula is being supplemented by evidence of a southern route across the Bab al-Mandab Strait into the Arabian Peninsula. At times of lower sea levels and higher rainfall, what is now a harsh desert was a lush landscape of lakes and rivers known as Green Arabia. These environmental windows opened and closed over thousands of years, acting as both barriers and bridges. Stone tools found in the United Arab Emirates and Saudi Arabia suggest that modern humans were already exploring the interior of the peninsula as far back as 125,000 years ago. This implies that the exit from Africa was not a single, desperate dash, but a series of rhythmic expansions tied to the changing climate of the planet. As we look at this new map, we see that the story of humanity is one of incredible resilience and adaptability. We were not a species that stayed put. Even with the simplest of technologies, our ancestors were crossing vast oceans to reach Australia 65,000 years ago, an achievement that required crossing the deep waters of the Wallace Line, which never had a land bridge. They were surviving in the high altitudes of the Tibetan Plateau and the freezing tundras of the Arctic. Every new archaeological site found in the deep strata of the Earth confirms that early humans were far more mobile and far more curious than the history books once suggested. This new perspective forces us to abandon the idea of human history as a steady climb toward progress. Instead, we see a history of trial and error, of civilizations and cultures that flourished and then faded, leaving behind only the faintest traces for us to find. It is a story of a species that was constantly reinventing itself in response to a changing world. When we look at the genetic signatures of modern populations, we see the remnants of these ancient journeys. We see the echoes of lost lineages and the shadows of migrations that occurred long before the invention of writing. The academic community is now moving toward a more holistic approach to reconstructing the past. We are no longer relying solely on the shape of a skull or the flaking pattern of a stone tool. We are using ancient protein analysis to identify species from tiny bone fragments. We are using satellite imagery and LiDAR to find hidden structures beneath the jungle canopy or under the desert sands. We are using paleoclimatology to reconstruct the exact weather patterns our ancestors faced 10,000 generations ago. This multidisciplinary effort is what has allowed us to draw this new map, one that is more inclusive of the diverse ways in which humans have occupied the Earth. Ultimately, the new map of the human journey teaches us that our history is much deeper and much more interconnected than we ever realized. We are the products of a massive global experiment in survival. The boundaries we draw today between cultures and nations are invisible when viewed through the lens of deep time. On the scale of 50,000 years, we are all travelers, all descendants of a restless species that refuse to be confined by geography or climate. The evidence buried deep in the Earth does not just challenge our old theories. It expands our sense of what it means to be human. It tells us that we have always been explorers, always been innovators, and always been part of a single, sprawling, and incredibly complex story. As we continue to dig and to sequence, the map will undoubtedly change again. There are still vast regions of the world, such as the Amazon basin and the interior of Central Asia, where the archaeological record is only beginning to be explored. There are likely other species of humans yet to be discovered and other great migrations that remain hidden in our DNA. But the framework we have established now provides a much more robust and dynamic foundation for future discovery. The human journey is no longer a straight line, but a vibrant tapestry of life, woven across every corner of the globe over hundreds of thousands of years. It is a map that reflects the true scale of our heritage, inviting us to look back with a sense of wonder at the incredible path that led us to the present day. This new map is not just an academic exercise. It is a mirror that shows us our true selves, a species defined by its ability to move, to adapt, and to survive against all odds.